welcome to our video presentation about solar-powered home. In this video discussion, dito natin matatakal or i-present namin kung paano yung working principle, yung description at kung ano yung mga types ng solar-powered home. So, bibigay din kami ng mga full details kung paano ba ito nag-ooperate or i-install or kung ano yung mga proseso na dapat nating gawin kung sakaling gusto nyo magpa-install or magkaroon ng photovoltaic system or solar power home. So let's get into it.
So we are here now, solar power. So in this discussion, it's like global energy. Dito yung process natin is yung alam natin na solar, yung typical solar which can be installed in our home. So since alam naman natin yung working principle system, in this type in this discussion, are going to discuss the working principle or kung paano sa different types, yung mga parts na kailangan ay dapat gawin kung saan gusto ng solar sa bahay. So let's start. In this type of solar powered home, meron ditong tatlong configuration. Yes, yung the three configurations. Isa is the grid tied, the off-grid, and the hybrid. So first is the grid tied. So a grid tied solar power system is connected to the home and to the traditional electricity. This type of solar system does not include sorry for the typographical error and storage battery. So ang grid-tied system or ang grid-tied solar power system, ito yung type of environment. Ito rin yung type ng solar which is na-connected sa traditional electricity grid. So meaning, pag walang kuryente, automatic wala rin kuryente kahit naka-solar, dahil walang include na storage. So meron ditong mga proseso kung bakit, or merong explanation kung bakit magkakabit ka nga ng solar, pero kung wala rin kuryente, wala kang kuryente kasi nga dahil sa dito sa configuration ng grid tied, ang main goal lang is to save money from electricity. So ang grid tied daw sa electricity. So ang main purpose nito kasi is to save money from yung mga gastos sa electricity. So yun yan, sa grid tied, which does not include storage. The next one is the off-grid. Off-grid naman is yung kabalik. This type is a standalone system that is completely disconnected from power. It contains a large set of battery packs which stores energy to be used at night or at the times when the sunlight is there. So ang off-grid naman, yung off-grid, meron itong large set of battery packs which stores energy during the day. So, meaning na to, hindi siya na-connected sa electricity grid. So, diba, alakang ko rin, magkakaroon ka pa rin na power yung bahay na meron siyang large set of battery packs which stores energy. So, ang downside lang nito is like limited lang ata yung pag yung makukuha mong energy kasi hindi naman ganun ka-efficient siguro yung iba, tatayo ka ng ilang volts lang or mag-install ka ng ilang volts na kaya ng mga bahay natin lang. So, hybrid. Sa hybrid naman, isang dali explanation na ito, which is also connected to the traditional electrical grid and also has a battery bank na nakalagay. So, meaning, meron siyang battery backup and nakakabit din siya dun sa traditional electricity grid. So, meaning, kahit mawalan man ng kuryente sa halimbawa, may naalis ng or may naalis sa distribution utility na kailangan i-cut off ng power, magkakaroon pa rin ng flow of energy or sa bahay sila. May battery backup yung sa configuration natin which is yung so, dito tayo mag-focus sa grid. In grid type, the solar power system is being connected in parallel with the electric supply that goes inside the house functions. So, meaning yung grid type is nag-function lang that grid, but nakakalagay sa traditional electricity grid. Any excess energy that's being produced is then fed. So, yung excess daw na makukuha or harness ng energy solar power is napupunta dun sa grid or dun sa narinig dun sa network. So, may mga reporters or we have reporters here na explain kung anong mangyayari kung paano ba pwede kang makasave or ma-attain zero bill monthly mo sa electricity or kung paano na yung distribution utilities is ikaw pa mismo yung bata. So, sila yung magre-report ka. But, pag-ipapil lang is need mo kung pwede ka kumita dyan kung meron kang inverter with limiter or nag-apply ka ng net. So, ibang reporters yung mag-discuss dun sa net metering. So, since there is no battery backup, it does not produce power up. So, meaning, during the day lang siya efficient sa grid time. During brownout, the solar system is also in shut state, hence does not produce electricity. So, kapag cut yung power sa walang kuryente, automatic yung grid type solar power system wala na kuryente. The main purpose is to save electricity. In fact, when the solar array rating matches the electric consumption, zero bill penalty. When the solar ratings exceeded the day and night electric consumption, the system will be able to produce excess power which will be paid by the distribution. So, meaning lang neto, kapag yung kukuhang energy solar power mo lang na match lang sa electric consumption mo during that month, meaning zero bill natin or wala. Kung naman daw nagkaroon ng excess exceeding ratings nagkaroon ng excess or exceeding rating nakuhang energy or na-harvest ng solar, mapupunta yun dun sa grid and ikaw pa mismo babayaran ng distribution dun sa na-harness. So, dito naman tayo sa parts of the solar power. So, yung solar power, with tayo with or without limiter, or yung square wave or pure sine wave. DC circuit breaker, DC surge breaker, DC circuit breaker, You see surge protected becomes candidates which AC or DC wires, MC format cars, solar plus grids. So, dito muna tayo sa solar. Alam naman natin, ito yung pinakapamilyar sa lahat pagka sinabi yung solar. Ito yung parang siya yung solar panels. So, solar panel lang. The solar panel is the heart of the solar panel. So, kumbaga, ito yung parang importante part ng solar installation or solar panels. Kung wala yun, ano yung pangalas? So, a typical solar set will have a port. So, by connecting them together in series inside the panel, a more useful voltage is most small solar panels rated 150 watts or below are related as 12 volts, while larger solar panels are a 12-volt solar panel produces around 14 they put under. This allows a single solar panel to charge up to 12-volt battery. Incidentally, if you connect a voltmeter up the solar panel, it's not under. You will see voltage reading up to 36 volt. This is normal in the open circuit in a solar panel. As soon as you connect the solar panel, this voltage level will drop on the board. So, itong solar lang, description lang, lahat ng the solar power. Ito, electricity, then typically, board is usually rated 150 and 12 volts to 24 volts or minsan nagde-reach up to 26 volts. So, next. So, solar pa din naman, which is yung solar, monocrystalline versus polycrystalline. There are two types of solar panels, which is yung monocrystalline. So, tingnan nga natin kung ano pa yung mas efficient sa solar panels, monocrystalline versus polycrystalline. So, kung ano, yung silicon arrangement yung setup. Yung setup na call this powerful. Pero yung silicon arrangement, it's a monocrystalline. The silicon arrangement then is one pure silicon crystal, meaning isa but pure. So sa polycrystalline naman, many silicon fragments melded together. So hindi siya parain lang na pero hindi siya pure. So next one is the cost. Cost na itong mga solar types of solar panels, which is monocrystalline. So yung cost ng monocrystalline is more expensive and the polycrystalline is less expensive. Wait, there is a reason kung bakit differentiate nyo na bakit more expensive yung sa less expensive yung isa. I think it's obvious naman na kahit more expensive yung sa monocrystalline this is proven na much more effective or efficient. So kung may budget, kung kayo dito sa or hindi din plans monocrystalline kasi based dito sa pagkita na ibang aspects sa monocrystalline mas sulit na compared to sa crystal. So, yung appearance niya is yung panels ng monocrystalline na black blue and sa polycrystalline na blue hue. So, efficiency level. So, as I've said na kanina, mas mahal yun sa monocrystalline. So, efficiency ng monocrystalline is more efficient than the polycrystalline. So, ang lifespan ng monocrystalline is 25 to 40 years, while the polycrystalline is ranging lang up to 20 to 35 years. So, mas angat ng 5 years sa monocrystalline. Sa temperature coefficient naman, more temperature coefficient included more efficient heat. So, higher temperature coefficient then less efficient heat. So, based sa nakita natin aspects, so kung meron kang budget din, dito na sa monocrystalline. Pero, as I've watched the video discussion from my professor, so depende rin sa tao kung ano yung gusto. Hindi ko ba nila polycrystalline? Kasi depende rin sa appearance kung di ba sila active ay hindi na nabibili ko kasi o ganun. So, pero kung sa mga features and attributes, dito na tayo sa polycrystalline. It is much effective kung may budget na. Pero pwede naman sa polycrystalline. Ganun din naman. But efficiency-wise, polycrystalline is best. Sabi tayo sa circuit breaker. Kasi madali lang tong circuit breaker na to, it's just simple discussion or simple description lang. Ang circuit breaker is just to protect the system from overcurrent to short circuit overload. So meaning yung energy na nakakargas is ang function ng circuit breaker is to prevent the system from overloading or short circuit. So the RCDO stands for residual current operator circuit overload. So inverter. Sa inverter naman tayo, since produce energy or current na mostly or almost all of the DC or direct current. Ang function naman ng inverter is to convert the DC output of the battery to DC. So yun na yung description ng converts the DC output into DC, which is standard used by all commercial users. So yun na yung function ng inverter is to convert lang DC output into DC, which yung alternative current is one of the ways dun sa ginagamit siya mostly ng lahat ng commercial. So meron dalawang type na inverter na pwede mong makita yung pure sine wave and modified sine wave. So efficiency wise, para lang siyang select is called yung pure sine waves is is much better than modified sine wave because It is usually needed if you are cold tied to the grid. You need pure sine wave but sensitive. So, di ba, sensitive, mas maganda ilagay mo is yung pure sine wave converter kesa sa modified sine wave. Kasi nga, it is safe for sensitive. Sa modified sine wave, kung medyo may budget ka, pwede sa mag-pure sine wave ka na din. But kung wala naman, pwede din naman modified sine wave ka. Efficiency-wise, for the safety, or for the efficiency system mo mag-pure sine wave ka na. If kung ayaw mo naman ba, wala ng budget, gusto mo lang mag-tayo ng solar system available, modified sine wave is better. Modified sine wave is also great, but kung may pera ka, pure sine wave. So, SPD or surge protectors. Ang madali lang, surge protector device, this has one goal or one function, which is to generally protect the system from power surge. Diba yun? Ang circuit breaker and SPD or surge protector, kumbaga, filter out lang harness natin. Pwede may mas cleaner energy na dumadalo para dumalo yung energy sa system. So, basahin natin ang description ng surge protectors. SPD or surge protection device that protects the system from power surge or more appropriate for the voltage transfers. SPD directs this excess powers to the ground. Since solar panels are heavily exposed by transient voltage span across the light, either directly or so, surge protection device function is to protect the system from power surge. So, halimbawa, ito yung sinasabi mo na sabi rin ng professor na sa halip magkaroon na hanggang brown out or loss out. Huwag nyo bubuksan yung mga equipments or yung appliances that hold for at least 15 minutes to 30 minutes for safety from power surge. So yun lang. SPD is for surge protection. So hanggang dito lang po yung part ko. Yung other reporters are going to discuss some of the principles and parts of the solar powered homes. So I just leave it to them to explain furthermore about solar power. I hope learn something from my report and they will do the rest.
Or the surge protection device. So ano nga ba yung surge protection device? So, yung surge protection device protects the system against power surge or yung tinatawag natin na transient voltage. So, para mas maintindihan kung ano yung SPD or surge protection device, SPD generally protects the system from power surge or more appropriately called voltage transient. SPD redirects this excess power to the ground. In photovoltaic system, since solar panels are heavily exposed in the environment, transient voltage is primarily caused by lightning, either directly or indirectly. So, multiple interconnection within power cable is very susceptible ball to electromagnetically induce transients where power surge could also arise. Transient voltage is the occurrence of very high voltage in a very short duration of time, around tens to hundreds of microsecond. Exposure to this transient voltage may cause a catastrophic component damage leading to system failure. So, para mas maintindihan natin, yung surge protection device nga daw, ito daw yung nagpoprotekta sa ating system against power surge or called transient voltage. So, kung hindi natin alam yung transient voltage, ang transient voltage, ito yung panandaliang pagtaas ng voltahe or panandaliang sobrang pagtaas ng voltahe. So, saan nga ba nanggagaling yung tinatawag natin na transient voltage? So, nanggagaling ito primarily caused by lightning or sa mga nakukuha natin ito pagka kumikidlat sa labas. So, then ngayon, doon papasok yung ating surge protection device. Yung SPD natin, bago pa makapanira ng photovoltaic system or setup, itong si transient voltage, idinadivert na niya papunta sa ground and then ground na yung mag-a-absorb ng transient voltage. So, yun yung role ng ating surge protection device. So, the DC SPD are placed parallel to the DC CB. So, ito naman isa yung AC surge protection device natin. Kung kanina, ang pinag-uusapan natin is sa DC, ngayon naman is sa AC. So, yung AC surge protection device offers the same protection as the DC SPD. How this time it is on the AC side nga, yung sinasabi ko. So, the AC SPD are placed parallel to the AC CB. Just like the DC SPD, these serve as protection against transient voltage, but this time on the AC side of the photovoltaic system. SPD redirects this excess power to the ground. Multiple equipment connections on the grid, either internal or external, can also be a cause of electrical anomalies where power surge could also arise. So, yung AC SPD natin is same lang siya ng function ng DC surge protection device. So, next naman is the time delay switch. So, yung time delay switch natin is tinatawag din natin itong power or delay switch or power switch. So, ano nga ba yung tinatawag natin na power on delay? So, it delays the turning on of any electronic device for a desired time interval. So, this device serves its useful purpose usually when brownout occur. So, after a brownout, when power have already been restored, there is the tendency of power surge, which may damage the system if it's being turned on right away. To prevent this, time delay switch delays the turning on of the system for a minute or even a bit more. So, para mas maintindihan natin is i-elaborate ko pa rin siya. So, sa gabi, di ba, usually pinapatay ang grid tied setup. And then, binubuksan ito sa umaga. So, kapag binuksan na, hindi pa agad magkakaroon ng power within the system. So, si delay switch, i-delay muna niya yung all set of power and the delay can be adjusted. So, yung usefulness ng time delay switch is during brownout. Diba? Pagka naman nagba-brownout sa atin, laging sinasabi sa atin sa bahay ni mama or ni papa na wag mo nang pagka nagka-brownout, siguraduhin mo nang pinatay lahat ng ilaw, patay yung electric fan, yung saksak ng TV. Kasi kapag biglang nagka-power, tapos naiwan nating bukas yung ating appliances, is maaari daw masira. Ganon. So, yun yung tinatawag natin na time delay switch. So, next naman is yung tinatawag natin the net metering program. So, ano nga ba yung tinatawag natin na net metering? So, yung net metering, ito naman yung batas na nagpapahintulot para makapagtayo tayo ng sarili nating renewable energy facility sa mga bahay-bahay or within the facilities para may sarili tayong pagkukunan ng ating kuryente. So, yun nga, yung net metering allows customers of distribution utilities to install an on-site renewable energy facility not exceeding 100 kilowatts in capacity so they can generate electricity for their own use. So, any electricity generated that is not consumed by the customer is automatically exported to the DU's distribution system. And then the DU gives a peso credit for the excess electricity received equivalent to the DU's blended generation cost, excluding other generation adjustments, and deducts the credits earned to the customer's electric bill. So ngayon yung sinasabi ko na yung net metering is ito yung batas na nagpapahintulot na makapagtayo tayo ng sarili nating renewable energy facility sa mga bahay-bahay are within our facility para magkaroon tayo ng sariling pagkukunan ng ating kuryente. So, is net metering already available in the Philippines? So, oo naman, noong May 27, 2013, the Energy Regulatory Commission adopted ERC Resolution 09 Series of 2013 approving the rules enabling the net metering program for renewable energy. So, yung resolution nito is na-publish siya noong July 10, 2013 in newspapers of general circulation in the country at ito ay and took effect 15 days thereafter. So, the net metering rules took effect in the Philippines on July 24, 2013. So, yung net metering rules is na ito sa Pilipinas noong July 24, 2013. So, sa ibang bansa, syempre, meron na agad silang ganitong batas. Pero dito sa atin, sa Pilipinas, yung net metering natin is hanggang 100 kilowatts lang ang pwede nating itayo. So, may mga benefit ba na makukuha sa ating metering? So, meron syempre. By generating electricity for own use, you reduce the amount of electricity you buy from your local DU. The rate of savings or avoided cost realized on electricity generated for own use is equivalent to the DU's retail rate consisting of stages for generation, transmission, system loss, distribution, subsidies, taxes, and other charges. So you also earn peso credits on any excess electricity exported to the DU equivalent to the DU's blended generation cost, excluding other generation adjustments. So, the peso credit earned is then used to reduce your electricity bill. So, may para mas lumawak yung ating kaalaman, may benefit daw ba tayong makukuha kapag gumamit tayo ng net metering. So, meron, 'di ba? Grid type solar powered home has the tendency to export a certain amount of power towards the grid, and yung amount ng power will enter to our meter. And it will reflected on our electricity bill. So, 'di ba, mapapansin natin kapag nagpakabit ka ng solar, kung kailang may solar ka, saka naman tumataas yung bilang ating kuryente. So, para maiwasan natin yung ganong senaryo, kailangan mag-apply tayo ng net metering. So, paano mo ba mamonitor yung excess energy ng iyong grid type setup is exporting towards the grid? So, the DU may to install two directional one to meter energy you buy from your local DU, and the other to meter the energy you export to the DU. So, kapag nag-apply ka ng net metering, papalitan na ng distribution utility yung kontador sa ating bahay. So, ulitin ko. Kapag nag-apply ka ng net metering, papalitan na ng distribution utility yung ating kontador sa bahay. Minsan, dalawang kontador yung nilalagay sa ating bahay. Yung isa na kontador is pang monitor sa papasok na kuryente, yun yung nanggaling mula sa grid. Nandun yung isang kontador naman, ito yung magmo-monitor ng kuryente na inilalabas ng solar setup papunta sa ating grid. Pero usually, or kadalasan, sa isang kontador na lang ang inilalagay sa ating bahay at capable na yon sa pag-monitor yung palabas at yung papasok na kuryente. So, sino-sino nga ba yung mga qualified na mag-participate sa net metering program? So, DU customers who are in good credit standing in the payment of their electric bills to their DU are qualified to participate in the net metering program for renewable energy. So, these customers are referred to in the rule as qualified end users. So, kapag wala kang kulang sa kuryente or wala kang in-avoid na batas sa DU or sa distribution utility, syempre, pwede kang mag-participate sa net metering program. Kapag wala kang kulang sa kuryente or wala kang nilabag na batas. So, may mga consequences ba of not applying for net metering? So, in the case that solar power system is being installed and doesn't apply for net metering, any excess energy that is being fed to the grid will be billed to the customer. Example is when the solar array is rated at 5 kilowatts and the load consumption is only 4K. So, the system will have an excess of 1 kilowatt which will be sent to the grid. This excess energy will pass through the meter, hence will be billed to the owner. So, yung mga excess energy daw na ini-export ng system papunta sa grid is papasok siya ngayon sa ating kontador at magre-reflect ito sa ating electricity bill. And then, is there any other way besides net metering that a customer having a solar system producing excess energy during the DA and yet will not pay for it? So, meron daw bang ibang way bukod sa net metering? Syempre, ang sagot dyan is yes. This can be achieved by using an inverter with limiter. So, pwede kang, besides sa net metering, pwede ka din gumamit ng tinatawag natin na inverter with limiter. So, itong device ito yung nagdi-limit ng power that the system will dissipated. So, it automatically detects the maximum power that the system can provide without the excess being sent to the grid. So, yung net metering daw, automatically daw niyang madidetect yung mga maximum power sa ating system na napoprovide ng ating system without the excess being sent to the grid.
So let's move on to circuit connections. Kung ano ba ang mga connections sa loob ng isang solar panel system. First, we have the wire sizing. And under wire sizing, we have TW, or the TW stands for thermoplastic wire. It is good, or it is used for moisture resistance and flame retardant. So usually, ang ginagamitan nitong TW ay yung mga internal wirings ng mga appliances like aircon, refrigerator, electric fan, and etc. Next, we have THW. The THW stands for thermoplastic heat resistant wire, moisture resistant, and flame retardant. So, ito na yung medyo kumakapal na yung coating niya. So, direct exposure from sunlight, okay na rin siya. And, hindi na rin siya agad-agad natutunaw kapag expose sa heat. And next, we have THHN, or THHN stands for thermoplastic high heat resistant nylon coated. So, ang THHN, designed for specific insulation material, temperature rating, and condition of use suitable for dry and damp locations. So, damp locations, ginagamit siya sa mga damp locations. Ito yung mga sa labas na, ganun, pwede na siya sa labas. And meron na rin siyang, hindi lang isa yung coat niya, kundi meron na rin nylon na coating. So, ayun nga, specific siya for high heat, as in, mainit, okay siya sa ganung place, pwede siyang gamitin na wire. And next, we have the THHN or THWN2. THWN2 is similar to THHN, except it is water resistant, adding the W into the acronym. So, hindi lang basta pwede siya sa high heat, kundi ay pwede na rin siya sa or water resistant na rin siya. THWN is rated up to 167 Fahrenheit or 75 degrees Celsius in wet environments, but its successor, THWN2, is rated for 90 degrees Celsius in both wet and dry environments. Historically, THHN and THWN were separated wires, but now you'll typically find them capabilities combined in the THHN/THWN2 design. So, dati daw, magkahiwalay pa yung dalawa na to. So, parang may mga specific pa siyang, kunwari, for yung place na lalagyan mo is masyadong mainit, so you're gonna use THHN, or kundi man, mostly, ang kakabitan mo naman ay may mga basa din or may mga tubig din, so you're gonna use THWN. And ngayon, meron na rin tayong THHN, combined THHN and THWN2 design. So, pwede na siya sa parehas na sobrang init at sa basa. Next. Here's a breakdown to help make some sense of the lettering. The T stands for thermoplastic insulated cableway. Single H means the wire is heat resistant, and HH means the wire is heat resistant and can withstand a high temperature. So, and N means nylon coated, and the added W signifies that the wire is also resistant to water. So, yun ang mga iba't ibang uri ng mga single-stranded na wires. Thank you.
So ayun na, tuloy lang natin yung report. Dumako tayo din sa PB wires. PB wires. This type is an exclusive kind of wire created for PB application. So yung PB wires, isa siyang exclusive wire na created para sa mga photovoltaic applications. This cable behave extremely well in very hot temperature. So, yung cable daw na to, maganda yung performance niya in terms of hot temperature and other harsh environmental conditions. Its special characteristic compared to other wire is its insulation and outer sheet, which is made up of XLP, E or ERP. So yung pinagkaiba niya sa mga typical na wire is yung insulation and outer sheet niya. Ayun nga, gawa siya sa XLPE or ERP. O ano ba XLPE? XLPE is an acronym for cross-linked polyethylene. XLPE is a thermosetting polymer, meaning that the material polyethylene or PE is cured under heat, and in that process forms bands in all directions, forming a three-dimensional matrix. So ERP means ethylene propylene rubber. Next, so you can see in the picture, meron tayong iba't ibang size ng wire. So kung mapapansin nyo, sa number ng wire, the more na mas maliit yung number ng wire, mas mataba yung wire. The more na mas malaki yung number ng wire, mas maliit yung wire. So kung mapapansin nyo, yung number 3 gauge, mataba siya. Kumpara mo dun sa number 14 gauge na manipis lang siya. So yun lang naman yung pinupunto din na mas maliit yung number, mas mataba. Mas malaki, mas mapayat. So dumako na tayo din sa NEC table 310.15B16. So din pinapakita lang naman yung temperature rating ng mga conductors. And ayun, sa ayun, Sa table, naka-indicate dyan yung size, yung types, yung TWD, UF, under ng 60 degrees Celsius, yung RHW, THHW, THW, and so on. Ang temperature rating niya is 75 degrees Celsius. Yung mga THH naman, yung mga THHW, ayan yung mga kadalasan natin ginagamit sa photovoltaic applications. Nagre-range sila from 90 degrees Celsius. Kapag mga TW naman, UF 60 degrees Celsius, THHW, 75 degrees Celsius, TBS, SA, SIS, and so on, nag-range sila from 90 degrees Celsius. So, ayun lang naman. Pinapakita lang sa table na to yung temperature rating ng mga conductors. Okay, next na tayo. Table 310.15.3c. Ambient temperature adjustment for raceways or cables exposed to sunlight on or above rooftops. So sa table na to, may dalawang column. So yung unang column is distance above roof to bottom of raceway or cable, and yung temperature other on roof 0 to 13 millimeters or 0 to 1/2 inch. Ang temperature other natin gagamitin dyan is 33 degrees Celsius kapag mas mataas doon siya ng 0 to 1/2 inch above the roof. Above roof 13 millimeters or 1/2 inch. So kapag daw mas mataas ng 1/2 inch sa roof natin yung cable, mag-a-add tayo ng 22 degrees Celsius. Kapag above 90 millimeters or to 300 millimeters or 3.5 inch to 12 inch, mag-add tayo ng 17 degrees Celsius. Kapag above 300 millimeters naman to 900 millimeters or 12 inches to 36 inches, mag-add tayo ng 14 degrees Celsius. Okay. Ayun lang naman, pinapakita lang din yung pag na-expose yung cable dun sa or may effect yung height ng nakaka-apekto yung height ng cable dun sa temperature. Okay, sa next table naman, dito pinapakita lang yung size ng wire natin or yung conductor, yung sa cross-sectional area niya, yung weight niya sa overall diameter. So, yun sa size, yung sa AW, circular mills. O kapag cross-sectional area naman, square inch, square millimeters. Pag weight, pound per feet, or kilogram over km. Overall diameter, inch or millimeter. So, next na tayo dyan. Table 240.6a, standard ampere ratings for fuses and inverse time circuit breakers. So ito lang naman yung mga standards na amperahin natin sa mga fuses natin and sa mga circuit breakers. Ayan, kung mapapansin nyo, nagre-range siya from 15 to 6,000 amperes. No, kalaki, no? So ayun, next na tayo dyan. Okay, next table, temperature rating of copper conductor. Ayun, meron ayun, sa size, sa types, tapos yung temperature niya parang kamukha lang ng naunang table na din-discuss ko. Kaya lang ito carried rating to. Next na tayo dyan. So, naulit lang na-discuss ko na to kanina. So, tara try natin mag-solve ng problems regarding in photovoltaic system conductor sizing. So, paano ba sinasolve yun? Yung paano natin mahanap yung perfect size ng conductor natin. So, step 1, look for the ISC rating of photovoltaic cell. So, hanapin mo muna yung ISC rating ng photovoltaic cell mo. And step 2, multiply by 2 factors irradiance and continuous duty. So i-multiply natin ngayon yung ISA rating mo and magiging IPB nyo natin yun. Ibig sabihin, yung 1975, ita-times natin sa 1.25. Pag kinalculate natin yan, nalalabas yan 15.23 amperes. Step 3, refer on table 310.15, 16 for the size of wire. The table indicates number 14 THHN with an ampacity of 25 amperes since number 14 AWD is not the best practice for PV system. Use number 12 THHN with an ampacity of 30 amperes. So, mag-refer daw tayo sa table na naunang diniscuss ko. And kung mapapansin natin yung number 14 THHN doon, may ampacity siya na 25 amperes, pero hindi sinasuggest ng mga experts yon. Hindi magandang practice yun. Kaya mas mainam na ang gamitin natin is yung number 12 na may ampacity na 30 amperes. Sabi nga, mas okay ng sobra kaysa kulang. Sa step 4, ampacity correction due to ambient temperature. Since Philippines ambient temperature is around 37 degrees Celsius, the table 310.15 to a indicates 30 times 0.91 is equals to 27 amperes. So ayun nga, magkakaroon pa tayo ng ampacity correction due to ambient temperature dahil alam naman natin din mainit sa Pilipinas, yun nga around 37 degrees Celsius tayo. So mag-base tayo dun sa table 310.15. B2A, ini-indicate niya na yung 30 ita-times natin siya sa 0.91, and yung bago nating ampere is 27 ampere. So step 5, ambient temperature adjustment due to rope wire distance for 1.5 inch above roof. 37 plus 22 is equals to 59 Celsius. So ayun nga, diniscuss ko din yung nakaka-apekto yung taas ng wire sa yung distance ng wire between sa roof. So ayun, dahil nga ang ginamit natin is 1/2 inch above roof, mag-add tayo ngayon ng 2 degrees Celsius. So 37 plus 22 is equals to 59 degrees Celsius. Ayan, the table 310.15 to A indicates 27 is equals to 0.71 is equals to 9.17. So ayun, pag magre-refer tayo sa table 310.15 to A, ini-indicate niya na yung 27 ito times natin sa 0.71. So magkakaroon tayo ng panibagong 19.17 amperes. Since 19.71 amperes, A is greater than 15.23, our selected number 12 wire will fit the system. So ayun, in conclusion, magpipit daw yung number 12 size na wire dun sa system natin. So next lang tayo, no? Step 6, since there's only 2 wires inside the conduit, this step can be now bypassed. So pwede na nating i-pass yun since nga na meron lang dalawang 2 wires inside the conduit. So step 7, adjustment due to voltage drop. So ayun, i-adjust natin. Siyempre meron din mga voltage drop na mag-occur dyan. Kapag yung voltage drop is less than 3%, yung gagamitin natin formula is BD is equals to 2IR, where R is equals to K LA. BD is equals to 2.93, 12.9 times 25 over 6,530 is equals to 0.92 volts. So, kukunin natin yung percentage. 0.92 over 32.26 times 100 is equals to 2.85%. Since 2.85 is less than 3, are selected number 12 will fit the system. But since 2 over 85 is a bit near 2.85 is a bit near to 3, it would be better to use number 10 THHN wire for additional safety factor and for our future expansion. So ayun nga, yung voltage drop natin, nalaman natin na meron tayong 2.85. So less than 3 siya. So yung pinili nating size ng wire is na number 12 is magpipit pa rin sa system. But since nga na malapit siya sa 3, mas mainam na mag-adjust pa tayo ng size. So for the additional safety factor, mas mainam na gamitin natin yung number 10 size na wire. On the previous problem, in case the voltage drop exceeded 3%, so ayun, kapag daw nag-exceed sa 3%, sabihin natin 5%. Since the initial selected wire is number 12 THN, make a one-step higher adjustment. Select initially 10 HN. BD is equals to 2.923, 12.9. 25 over 10,380 is equals to 0.0558 volt. The percentage kukunin natin 0.058 over 32.26 times 100 is equal to 0.18. So ang magpipit na ang pinaka-ideal and magpipit na size ng wire system natin is number 10 THHN. Ayan, note lang din yung K, yun yung direct current constant. This is a constant representing the direct current resistance for a 1000 circular mills conductors that 1000 feet long at an operating temperature of 75 degrees Celsius. The direct current constant value you should use for copper is 12.9 ohms and 21.2 ohms for aluminum conductors. The K constant is suitable for alternating current circuit where the conductors do not exceed number.
Inverting sizing. For the inverter to fit the system, its power rating must be approximately equal to the power rating of the solar arrays, or maybe a bit greater of around 10% to 20%. Therefore, if your solar system is rated at 2000 watts, you will need a solar inverter that is about 2000 watts. An inverter that is way below the power rating of solar arrays cannot maximize the power that the solar arrays are capable of. And an inverter that is way above the power rating of solar arrays will have a noticeable drop in efficiency in our example, which is rated of around 200 watts. 900 times 1.1 equals 190. Use 1 kilowatts grid tie inverter. So, ang kailangan daw para mag-fit sa system is a bit a grade around 10 to 20%. So, kailangan daw, yun nga, kailangan mas mataas daw sa 10% or 20% kapag mag-fit kayo ng inverter. So, next, DC and AC circuit breaker sizing. First thing to consider in sizing a CB for PB system is the ruling in PEC, which states that PB circuit current is continuous. Thereby, the minimum OCPD rating is 125% of the maximum current. PEC 2017 Article 6.90.22b and Article 6.90.2.3b. Therefore, in reference to the problem in conductor sizing on the DC side, the max current is 15.23 multiplied by 125%, that is 19.04. Use 20 ACB on the AC side since the inverter rating a 1 kilowatts, dividing this by 220 volts. The current will be 4.5A multiplied by 125%, that is 5.625A. use CACB. So, ang max current daw ng DC is 15.23 kasi minultiply siya sa 125%. While sa AC naman is 220, 4.5 multiplied by 125% is 5.625. So yan, sa DC 15.23A and sa AC naman is 5.625A. So yan, yun yung max ng AC and ng DC. So minumultiply siya sa 125%. So what is 125%? Yun yung the minimum OCPD rating. Doon natin nakuha yung 125%. Kaya doon natin siya minumultiply. So next, the rule is simple in sizing of surge protection device. Basically, the UC rating of the SPD should match the system voltage or a bit higher, 15% to 25% for SPDs to attain a longer lifespan. Therefore, in reference to the problem in conductor sizing, for the DC side, use SPD with UC rating of 100 V120 V. For the AC side, use SPD with UC rating of 230-275 V. In normal discharge current, maximum discharge current, UC, maximum continuous operating voltage or MCOV, voltage protection rating or BPR, or surge voltage rating SVR or clamping voltage. So dito makikita natin yung mga yun, nominal discharge current, yung mga parts ng surge protection device. So yun, maximum discharge current. So yun, pag sinabi natin MCOV, maximum continuous operating voltage, BPR for voltage protection rating, and SVR for surge voltage rating. So ang voltage naman dito is bit higher, 15% to 25%. So mas mataas siya ngayon. Next, solar panel orientation. On those countries located at the northern hemisphere, solar panels should be facing south direction for maximum sunlight, while in the southern hemisphere it should face north. Since the Philippines is above equator, it belongs to the northern hemisphere. Thus, solar panels should be facing south direction for maximum efficiency. A general rule for optimal annual energy production is to set the solar panel tilt angle equal to the geographical latitude. Essentially, the closer a solar panel is located to the equator, the more the panel should be pointing straight up. The closer the panel is to the poles, the more they should tilt towards the equator. Therefore, in Philippines, in the solar panel, tilt should be 12 to 14 degrees. So, pag sa northern hemisphere located, yan. Solar panel should be facing south direction for maximum sunlight, while in the southern hemisphere it should be face north. So, kapag pag north, south kailangan yung nakalagay yung solar panel. And kapag south naman, nakalagay dapat yung north sa solar panel. So, parang magkabaliktad. Sa Philippines naman, kailangan 12 degrees nakatilt. Para sa degrees para sa solar panel. So, above equator daw yung bandang Pilipinas. Zero bill. Bill compute for your monthly average kilowatts. Use 300 kilowatts. Convert to daily usage. 300 kilowatts divide 30 days equals 10 kilowatts day equals 1,000 or day. In the Philippines, peak sun hours 5 hour day for solar array rating 10,000 divide 2,000 watts. For zero bill assurance, 2,000 times 1.1 equals 2,200 watts. Number of panels 2,200. 300 equals 7.33 equals 8 solar panel. So yun, ang estimate na oras natin kapag mainit yung araw or sikat yung araw is yung 5 hours. So yung 5 hours na yun, doon natin pwede makakolek ng solar power. Yan, saan ba galing yung solar power? Syempre, solar power galing sa rays ng sun. So kaya inano natin siya sa 5 equals 2,000 watts. So yung ratings na nakukuha natin ng lakas na galing sa araw.